Welcome to our quantitative methods session in linear regression, where we're going to learn how to predict events using illustrations of equations. So we are going to use an X or Y plane to explain linear relationships. So relationships exist in organizations. Relationships exist in many fields of study. So there are three kinds of relationships that we're going to look at. So of any kind of relationship, as long as it's linear, we have three types of relationships. It can be a positive relationship, it can be a negative relationship, or it can be a no relationship at all. So when you have a positive relationship, your linear regression equation is upsloping. It's like this. So our linear regression equation is given by y is equal to a plus bx. So a stands for the y-intercept, where it's cutting the y-axis. B stands for the slope, the gradient. I'll explain all these terms later on. So this is a positive relationship, and the positive relationship can either be strong or weak. So examples of positive relationships that we have could be advertising and um, sales. The more you advertise, the more sales you're going to have. Except that you could have a strong relationship because as you advertise, even by a bit, you have more sales, or you can have a weak relationship. Okay, depending on what we're talking about between the independent variable and the dependent variable. So the linear regression equation is given by y is equal to a plus bx. So the b is calculated alone. It's given by the formula. Of course, the formulas could be given, not knowing what your lecturer said, or you can learn how to use the calculator. Everything will be done for you by the calculator. So the formula for the gradient b is given as follows: n summation of x squared minus summation of x. So these formulas will be given. Don't worry about them. So on top we have the n, which is given by the sample size. Summation of x means when you total up the x column, all right? Then we're going to have below here we have n x squared minus summation of x to the power 2. And here summation of xy and a summation of x and summation of y. All right. Then the a is called the cutting point, the y-intercept. It's simply given by summation of y over n minus the slope, summation of x over n. So we've talked about the first scenario, that relationships can either be positive or negative. So we're talking about the positive relationship that we have there. Positive relationship can come about dealing with situations like when one variable increases, the other variable also increases. That's a positive relationship. A negative relationship is also called an inverse relationship. This one occurs when the opposite is happening. When an increase in one variable results in a decrease in the other variable. That is called an inverse relationship. So inverse relationship can be epitomized by demand and supply. The demand function, in short, when the price increases, the quantity will decline. So in like manner, the regression equation for a negative relationship is only different on the slope. We have a negative slope here. So the relationship could be strong negative. It can also be weak, negative. So this is our scenario here. When the dots are very apart from each other, it means the relationship is weak. And what we use to determine whether the relationship is weak is what we call the coefficient of correlation and the coefficient of determination. So coefficient of correlation tells you whether the relationship is a positive relationship or the relationship is a negative relationship. That is the job of the R. When you square the R, it is called the coefficient of determination. It helps you measure the strength of the relationship, whether it is strong, moderate, or weak. So sometimes, yes, indeed, you can have a positive relationship, but the strength of the relationship is not as much. Okay. So
Collins, what's the second one? The one that helps you measure the strength?
the coefficient of determination is called the
Oh, okay.
coefficient of determination. So we have talked about three important uses of the regression equation. Number one, it is used to predict the regression using the regression equation. So for instance, you're able to know how much advertising you need to put in advertising budget to attain or obtain a certain sales level. So the first function is that of prediction. It is a predictor. So regression equation is a predictor. It helps you to determine. Sometimes you can use this equation to know or anticipate how much weight a certain body mass must have, all right? Using a regression equation. Number two, it is there to tell you the type of relationship using R. R means the coefficient of correlation. Coefficient of correlation. Coefficient of correlation can either be positive or negative. What is the formula for coefficient of correlation? It is given by R is equal to, it's almost close to the formula for B. Okay, so it is given by the following. Then here, on top we have the variation of xy. Then below we have the variation of x and the variation of y separately. So n x squared. So we have a lot of memorizing to do together. Don't worry. I'll help you memorize all these formulas, assuming your lecturer may not give you these formulas. Okay, so you have about 36 formulas to master before the exam. So these formulas should be in your mind. So I'll delve so hard in helping you know which formulas to use where. But the calculator is um, able to give you these answers even without knowing these formulas. So I just want you to understand the basic information here. So it is used to find the coefficient of correlation. Coefficient of correlation can either be a positive R or a negative R. A positive R means that X and Y are positively related. When one variable increases, the other variable also increases. What examples have we talked about? Supply. So when the supply for FRA, when farmers are told that supplying maize will give you so much at a high price. So the higher the price, the more suppliers are willing to come into the market. The third job of regression is to measure what the strength of the relationship. The strength of the relationship is R squared. R squared stands for coefficient of correlation. Coefficient of what? Correlation. A coefficient of determination. If you don't square it, it's coefficient of correlation. Coefficient of correlation is just positive or negative. Determination, it is to show you whether it is a strong relationship or weak relationship. So between 0 and 20%, that is a weak relationship. Between 20% and 50%, that is a moderate relationship. And above 50%, it is a strong relationship. So depending on how you want to bargain with your bosses, your R squared must make sense. For instance, if you're a marketer and you want to convince the board to give you enough money to do advertising. So they would want to see a correlation to say, is it more than 50? If we give you a certain amount to use for advertising, are we going to have so much sales? So we're going to now look at an example. For instance, we are given values of X and Y. Any questions so far before I proceed?
We can proceed.
Okay. So 1, 2, 3, 4, and 5. So these ones are our advertising. The sales could be 1,000, 1,000, 2,000, 2,000, maybe 4,000. All right. So now they're asking us to you plot the regression equation. You plot it and tell us whether it's a positive relationship or it's a negative relationship. So we can plot this here. Our y is always here, our x is always here on the horizontal. Okay. So the simplest form of linear regression is where we are dealing with two variables. The independent variable is what we call x. This is an independent variable. The dependent variable is what we call y, the result. So the cells depend on the advertising. Okay, so here we have 0, 1, 2, 3, 4, and 5. And here we have 1, 2, 3, 4, and 5. So the first part is asking us to sketch 1, 1. So it's 1, 1 is here. 2 on x and 1 on y. So 2, 1. 3, 2 is here. 4, 2 is here. 5, 4. So from the look of things, what type of relationship is this? Is this a positive relationship or it's a negative relationship? How are the dots arranged?
Positive.
It's a positive, right? Yes.
Mm-hmm.
Is this
Yes,
strong or
yes.
weak? Does it look strong or weak?
Mm.
It's strong. I think there's just one that looks out of place.
Okay.
I don't know.
Okay, yeah, it's strong. You can tell that it's somehow strong. Okay. So, but we can now confirm this by actually calculating it. All right. So can we proceed with the calculation now?
Yes,
Yes,
yes.
All right, to verify what our eyes are able to see and what is actually on the ground. So let us go with the computations. So remember, I've given you the formulas. At this moment, I assume because you have a new lecturer, I assume you're not given formulas. So we will need to calculate everything. Of course,
although he said the formulas will be given.
oh, even
So
better.
fingers, so fingers crossed that I think, yeah.
Uh,
Fingers and toes crossed that he
Yeah,
doesn't
yeah.
betray us.
Okay.
Sure.
Yeah. Okay. So let me assume on the worst case scenario, okay? Maybe sometimes lecturers betray. So here we've given X
Mm-hmm.
and Y. So the next step is to do what? To find column XY, okay? And the column X squared and Y
X
squared.
squared, I squared.
So what is XY? I'm applying column
So
X and column Y.
One,
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 then,
1, 2,
mm-hmm,
yes.
then,
6,
6, 8,
eight,
mm-hmm,
20.
20.
and then X squared,
1,
mm-hmm,
1,
4,
mm-hmm,
4,
9,
mm-hmm.
9,
16,
16,
and
25.
25.
Okay. And here Y squared,
1,
mm-hmm,
1,
mm-hmm,
4,
1.
mm-hmm,
Oh, 4, yeah.
4.
Is it? Oh, yeah, the next one is 4.
mm-hmm.
4
So, Collins.
and 16.
So this Y, right? Then and 16.
Oh, okay. We've gone to Y. I beg your
Yes,
pardon.
that's
Yeah, yeah.
16.
Yeah.
Yes.
Okay.
Mm-hmm. Yep.
Then the total here is scored summation of what? X,
X.
right?
Mm.
The total in the next
Yes.
column is called summation of what?
Y.
Then
Y.
summation of what?
X, Y.
Summation of XY. Then
Summation
X,
of the X
X
squared.
squared and
uh-huh.
X and Y squared.
Mm-hmm.
Then what is our N?
N is 5.
Good. The number of what? Rows. N is 5.
Right.
Mm-hmm.
Okay. And what is the total here? 15.
15,
Yes, 15.
10.
16, 20.
That's 7. 55. And 26, right?
Yes.
All right. So the first question was to sketch and to comment. The next question was to write the prediction equation, or they'll say find y on x. So what's the formula for the regression equation? Y is equal to what? A
A plus B
Plus
plus
BX.
dx. Good. And what was the formula for b?
It's that long one.
Who can try to remember
N
it?
summation. N summation X. Y.
B was n summation of xy. There should be xy on top. So
Mm-hmm.
together, xy, then minus, separate x
Summation of
times
X.
y,
separate X
x times y, right?
times yes.
All
Oh, it's
right?
multiplication at the top, eh?
Yes, yes. Then down,
Yes.
Summation X.
it's here the x alone. So n
Down
x squared
Mm-hmm.
X,
X squared
X squared
minus
minus
x to the power
summation
2.
X brackets.
What's the difference between x squared and function of x to the power 2?
mm,
This one
The
is,
first one,
uh-huh,
yes. So the first one, it's
mm-hmm,
summation X squared, right?
mm-hmm.
So meaning it's the one in the one, two, three, fourth column.
It's already squared on its own. You don't need to square it, yes.
Mm-hmm.
Then this one is a small x, but you now power 2.
Uh-huh.
All right, so let's substitute here. We're going to have what? 5, then 37, okay, minus
Mm-hmm.
15,
Minus, yes,
in
times, oh, in bracket,
times
10.
10. All right, over
Mm.
5,
So now that's summation X squared, so 55
uh-huh,
squared.
minus what?
That's the X now, 15
Uh-huh,
squared.
correct. So when you compute this, you're going to get 0.7. So where do you take the 0.7? Just on the B alone.
on the B.
So
Uh,
0.7 here. So you can't find A before
mhm,
finding B. Okay.
mhm.
Okay.
So what's the
All
formula
right.
Yes.
for A? Summation of what? Y
Y.
over N minus B, summation of X over N.
Over N.
What is the summation of Y?
It's
10
what? It's
10.
10.
over
10.
5
5.
minus what? What was our B?
0.7.
7.
And we just calculated. Okay.
Mm-hmm.
So if it is wrong, your A is obviously wrong. You know, summation of X?
Mm-hmm.
15.
Summation of X is what? 15
15.
15.
over
5.
5.
5. So here, 10 over 5 is what? 2.
It's 2.
Then 15 over 5 is what?
3.
3.
3.
3 times 0.7 is what? 2.1, right? So 2.1, 2 minus 2.1 is 0.1. Negative, right?
That's a negative, yes.
So where do we put that negative? On there?
A there.
Negative 0.1. Are we
There.
together?
0.1. Yes.
So we've written the prediction equation. Okay, now suppose they tell you that x is 1000. What is y? Suppose x, or they say suppose advertising is 1000. So we know that advertising is x in this case. Okay? Or let's just say suppose advertising is 10. Suppose x is equal to 10. That's y. Just for simplicity's sake, we just substitute here. So there will always be an issue of predicting one given the other. So where there is x, we put what? 10.
10.
So when you calculate that, you're going to get our y as what? 6.9. So it can come in terms of weight. Suppose 10 million was put as a budget. How much are you expecting in your sales figures? So we are predicting. Is that clear? Any questions at this point?
Okay, and the cells being the Y, yeah?
Yes, the sales being the y.
Okay.
Is this clear?
So we're calculating first of all the A and the B.
Yes.
Then the X will be given.
That's another question. Yes,
Then
you'd be given to say, suppose X, they'll give you a scenario. Suppose X was so much.
okay.
Okay, yeah.
All right.
That is why. All right. Okay.
Yes.
Is that clear? Any questions?
Yes, please just give us time just to copy. Is that fine?
Okay, sure. Of course,
Just a few.
I'm sending
Mhm.
I'll send you the video. I'm also sending the screen grab so that we don't spend time so much on
Okay.
Yeah.
Oh, you're sending the shorts.
yes,
Okay.
yes,
No
yes.
worries.
All
Fair
right.
enough. Mm.
Okay. So the next question is find R and R squared and interpret. Find R and R squared and interpret. So now R stands for what? R stands for
Coefficient.
coefficient of
It's coefficient.
correlation. What is the job of R?
Relation
What is the job for R? To show you whether it's a negative relationship or it's a positive relationship.
or a positive.
Yeah.
Uh-huh.
Remember you had told me from your observation what type of relationship was that? It
It was a
was
positive.
positive. Now we need to prove that, right?
Okay.
By calculating it.
Mm.
Okay. So I'm going to manipulate the B formula so that you know that it's not very different from B. You just need to add a few things. Okay. Are you getting me? Are we together?
Yes.
All right. Okay. So R is given by R is given by everything the same, but here we're going to multiply this one here times the variation in y. The y will be n summation of y squared minus summation of y to the power 2. Okay, it's just a continuation of b. So whatever we studied already here, we just extend it here. What is the variation of y? N, we start with n. N is still 5, right?
Still 5, yes.
Then summation of y squared. Y squared is what? 26, right?
6.
Minus what? Y to the power 2. What was our y? 10, right?
Y was 10. Yes.
Yes, 10 to the power 2. So when you compute this, our R will be 0.903 positive. So what is your comment?
It's a positive relationship.
Yes,
Positive
X and Y?
and strong.
No, not yet. Of course, you're predicting, yeah? R is just for the
Okay.
relationship. You can say X and Y are positively related. That's a comment, all right? X and
Uh-huh.
Y are what? Are positively related. That's all. Or
Mm-hmm.
they are directly related.
Mm-hmm.
Okay. Then the next question is asking us find the coefficient of correlation R squared. R squared is just you squaring the answer you got. 0.903. We square it. When you square it,
Mm-hmm.
we're going to get 0. What? 816. So you multiply this by 100 as a percentage. This means that 81.6% of Y is because of X. Okay? 81% of the sales are because we advertised. 81% of the dependent variable is because of what? The independent variable. Okay? That's what we mean in short. So you need to
Collins.
actually, based on what has been given. Let me repeat that. We first had to find R. The formula for R, I had to
Mm-hmm.
manipulate the B so that you understand that in case you forget it's one and the same, just add the variation of Y. So when you compute
Mm-hmm.
this properly, we found our R to be 0. What? 903.
903.
The interpretation here is based on the sign. We get a positive, is a positive relationship. We simply comment to say X and Y are positively related. A very good example I gave you is that of what? Supply. The higher the price, the more you supply. Is that clear on R?
Yes.
Yeah. Then we go to R squared. The same answer we got, we just square it to the power 2. We found 0.816. What is your comment? It is a strong relationship. Or 81.6% of Y is because of X. What if we found R squared as 0.9? What does it mean? 90% of Y is because of X. What if we found 0.1? 10% of Y is because of X. All right? Of course, 0.1 means a weak relationship. Are we together?
Yes, Collins.
Uh-huh.
So we just also need to remember what you were telling us about 0 to 20 being weak and
Uh-huh.
then above 50 is strong. What
Yeah.
was the middle one?
Moderate.
Okay, so moderate. So anything above 20 and below 50 is moderate.
Yes. Yes.
Okay, thank you.
Yeah. So this is in
So what if,
so
please?
for your exam purposes, I'm just trying to add depth, but otherwise your key concern is interpreting this in percentage. So what,
Collins, one question.
yes, please. Uh-huh.
One question. So it's up to 20. What if it's 21, it's already moderate,
Yes.
21%.
Yes. What if you got
Okay,
zero? What does it mean?
it's weak.
There's no relationship at all. Remember, I
There's
told
no
you.
relationship, sorry.
Yes.
Yeah.
So there are
So
times when,
so 1 to 20 weak.
mhm,
Any 0, nothing. Okay.
yes, there's no relationship. Sometimes there are relationships that we force that are not there. For instance, maybe age
Mm,
and experience. So when you're ARA, you need to interpret this. So this is mainly for your research purposes, for you to
okay.
understand your research. I teach research predominantly, so I'll record this information when you reach your final stage. So this is very important and very applicable. Are we together? Are we clear?
Yes, we are. Yes.
Okay, so this is where regression ends. So I'll give you homework from the project term test. I just want you to give me these three things. So I'll get the same document that you had as your assignment. I'll just change a few questions. I need you to find these for me. That will be your homework. Is that clear?
Okay.
Yeah. All right. So we end here. Unless there are any questions.